some stage. Mostly the calculator takes care.
Okay, understood. Thank you so much.
Okay. Okay. So
much
yeah, go
later.
ahead.
I joined much later, so if you don't mind, could you please send that video again, sir, regarding grade circles on the group?
Okay, I'll share that, beta. I'll share that. Okay, so today we will be proceeding ahead and going into the concept of vertex. What is this vertex? What is the use of vertex? Vertex basically helps us to get intermediate positions on the grid circle track. So once you have this vertex, you can get any intermediate positions which act like waypoints. After vertex, we will see how the intermediate positions can be calculated. So once the vertex is known, we can calculate the latitude, longitudes of intermediate positions. And after these, we will be going into the concept of composite sailing. So that is the plan for today. Okay, now one important thing, beta, some people have connected first time for the navigation lecture with me. So during the presentation, we will keep our mics muted, like everybody is muted at the moment. So once I am done through a particular slide or a particular topic, I will take a pause and I'll be asking you for your doubts. So once I ask you, then you can go ahead with all your doubts. You can unmute yourself, ask your doubts, and then we proceed ahead. So that helps us in the smooth conduct of the class. So before I go into the presentation, any doubts, any queries, anything you want to ask me, please go ahead, beta.
Sir, we already covered this in Napier's rule. Today we will cover this.
We have already covered, beta. I had shared a small video and a PDF document. So have you gone through that?
Yes, I have gone through that, but in this video only that great circle was there. Nothing about this GC Napier's rule.
You are not familiar with Napier's rule, beta?
No, I'm a little bit familiar with Napier's rule, but not too much, because I thought today we will do this Napier's rule and all. That's why I was not focusing on that.
Unfortunately, we have already covered that, beta. You have the spherical trigonometry book with you?
Yes, sir.
Just go to that spherical trigonometry book. There is a topic given initially, Napier's rule. Just follow that Napier's rule. Do a couple of questions. You will be through.
Okay, sir. I have a small doubt in Napier's rule. I will say this question. So later you can guide me, sir. I have a small confusion.
What confusion you have, beta? Can you ask me?
Yes, sir. I'll just review it.
Okay, Abhi, do one thing, beta. Do one thing. Whatever your doubt is, just hold on for the time being, because everybody else has done that topic. So just hold it with you. Once I cover the class, then I'll ask you for your doubts, or you can later on share on the WhatsApp group. We'll see to it. Okay.
Yes, sure. Okay, sir.
Okay. All right. Okay. Any more doubts or queries before we go ahead? Okay. All right. So great, beta. I am now going into the presentation. First, we are going into the vertex. So let me put up the presentation. So everybody is able to see the PPT on Vertex, beta?
Yes, sir.
Yes, sir.
Great, beta. Great. So we are moving ahead with Vertex. Let's go. We are now going to understand the vertex of a great circle. The position where the great circle reaches its highest latitude is called the vertex of that great circle. Let us try to understand it using a diagram. We have the diagram of the Earth on the screen now. You can see the Earth. We have the North Pole represented in the diagram. We have the South Pole, and exactly midway between them, this dotted line, black line, represents the equator. Now let us show a great circle on the Earth's surface. The green color circle which you see is a great circle on the surface of the Earth. This great circle plane is passing through the center of the Earth. The center of the great circle is same as the center of the Earth. It is a great circle. Now let us assume that we have a particular ship which is moving on this particular great circle. Let us assume that our ship is at this particular position A, where the great circle track is crossing the equator. Let us make the diagram of the ship. You see the ship now on the screen. The ship is moving on this particular great circle track, and at point A, the ship crosses the equator. Now, as the ship travels on this great circle track in this particular direction, after some time, the vessel is going to reach at this particular position. Let us call this position as position B, Bravo. You can see now that while going from A to B, the latitude of the ship keeps on increasing. Moving still further, at some point of time, the vessel is going to reach at this particular point, that is point Charlie. And if it proceeds further, it goes on the far side of the Earth, shown by the direction of the arrow. And after some time, you will see the vessel at this particular location, which is represented by position delta. Again, proceeding ahead, after some time, you will see at point Eco, the vessel is on the far side of the Earth and is crossing the equator again. Now it is crossing the equator from the north hemisphere into the south hemisphere. At point Alpha, at point A, it was crossing the equator from the south hemisphere to the north hemisphere. At point Eco, it has again entered into the south hemisphere. After some time, you will see the vessel will reach up to this point. This point is represented by Foxtrot. And after some time, it will reach at point Golf here. You can follow the laser pointer. And after Golf, if it keeps on proceeding on this great circle track, it will reach at this particular point Hotel. And moving further, it will again come back to position Alpha. Now, when the ship is proceeding on this great circle track, you will see there are two particular points or locations on this great circle track where the ship reaches the highest latitude. One point is the point Charlie. You can see point Charlie is the point where the ship reaches or attains the highest latitude in the northern hemisphere. And the second point is point Golf, G point, where the ship reaches or attains the highest southerly latitude. Both these points, that is point Charlie in the northern hemisphere and point Golf in the southern hemisphere, are known as the vertices of the great circle. So the position where the great circle track reaches its highest latitude is called the vertex of that great circle. Every great circle will have two vertices, one in the northern hemisphere and one in the southern hemisphere. When we are doing our great circle calculations, we are interested in the vertex which is closer to our departure and destination positions. Now, beta, any doubts up to here?
No, sir.
No, sir.
Very good. Great. Moving ahead.
Sir, I have a doubt. I'm not sure whether you will be clarifying it later on. That how do you verify whether the vertex is coming inside the page rate, like triangle or outside?
I'll tell you, beta. I'll tell you when we go ahead.
Okay, sir.
Okay. Now the vertices will be located with a d long difference of longitude of 90 degrees from the positions where the great circle cuts the equator. Let's try to understand this from the diagram. We know that it is at point alpha that the great circle track is crossing the equator. Now the vertex is attained at point Charlie. Now let us assume that if the ship crosses the equator at Greenwich meridian 000 meridian, by the time the vessel reaches the vertex, the meridian of point Charlie will be 090 degrees east. As the vessel moves further and goes on far side, it again reaches at the equator or crosses the equator at point Eco. The meridian of this particular point Eco will be 180 degrees. And again at its travels further and it reaches at point Golf, that is the vertex in the southern hemisphere. The meridian of point Golf will be 090 degrees west. So you can see the equator crossing happened at 000 degrees and another location was at Eco, that is 180 degrees. Both these points are diametrically opposite. The vertices are located exactly midway between the equator crossing points. So vertex Charlie is located exactly midway between Greenwich and 180, which is 090 degrees east. Likewise, the vertex Golf is located exactly midway between Greenwich meridian and 180 meridian, and this is at 090 degrees west. This is explained in the point. Vertices will be located with a d long of 090 degrees from the positions where the great circle track cuts the equator. Also, the latitudes of the vertices is equal to the inclination between the plane of the equator and the plane of the great circle. What this point explains is that the latitude of the vertex, we have a vertex at Charlie, so you can follow the laser pointer. This is the latitude of the vertex. This latitude of the vertex is equal to the angle of inclination between the equator and the great circle. You see this dotted line, black dotted line is the equator and our great circle is represented by the blue color track. The angle of cut, which is represented by this yellow color angle, the angle of cut or the angle of inclination between the equator and the great circle, gives us the latitude of the vertex. So beta, any doubt coming up to here?
No, sir.
No, sir.
Very good beta, great. Moving ahead. Now one very important property of the vertex is that at the vertex the direction of the great circle track is 090 and 270, or the direction of the great circle track at the vertex is exactly east-west. The great circle track is running in the easterly-westerly direction at the vertex. It is at this particular point the great circle track is closest to the nearest pole and farthest from the equator. You can have a look at the diagram. This is the vertex in the northern hemisphere, and it is at this particular point that the great circle track reaches closest to the north pole and is farthest from the equator. Now, considering the equator, equator is a special great circle having no vertices. Every point on the equator is at 0 degree latitude. So when you are moving on the equator, There is no point which is having a highest latitude. Every point is at 0° latitude. So equator is a special great circle having no vertices. Now this property that at the vertex, the direction of the great circle track is 090270 east west is very important property, and we use this property to calculate the position of the vertex. So please remember this property of the vertex going ahead. So clear up to here, beta?
Yes, sir.
Yes, sir.
Very good, beta. Great. Moving ahead. Now we have seen the property of the vertex, that at the vertex the great circle track lies in the east-west orientation or 090270 direction. Let us try to understand it using a diagram. We see the exact same diagram of the great circle track which we saw in the previous slide. Now let us assume that if we are looking at the Earth from this particular point, you see this yellow color arrow, we are looking at Earth from this particular direction. Now if we look at Earth from the direction of the yellow arrow, how is the Earth as well as the great circle and the ship going to appear? Let us try to visualize that. We are looking at Earth in the direction shown by the yellow arrow. On the left side, you are now going to see how it would look like if viewed from the direction of the yellow arrow. The North Pole will remain at the same location, South Pole at the same location. Equator will appear as a straight line if you are looking from the direction of the yellow arrow. The great circle track is going to look like this one. You see the great circle track. The arrows represents the direction of the motion. If you look closely, this particular point here, 000 meridian, will be this particular meridian here in the diagram. This represents the 000 meridian. You can follow the laser pointer. The vertical line in the center now represents the 090 meridian. 090 meridian was here. So it is represented exactly in the middle now. You are looking from the direction of the yellow arrow. So this 090 meridian goes exactly in the middle as this vertical line. The 180 meridian, which was on the far side of the Earth, now becomes this particular meridian. This meridian becomes 180 meridian. The ship was here at point alpha when it was crossing the 000 meridian. This point alpha is now represented here. This is the location of the ship, and you can see point alpha coming up. As the vessel proceeds ahead, it reaches at this particular point, which is Bravo. From point alpha, it traveled to point Bravo. The latitude increased. You can see from point alpha, it reached up to point Bravo. The latitude increased. From Bravo, the vessel moved on the great circle track up to point Charlie, which was the vertex at 090 meridian. From point Bravo, vessel moved along the great circle track up to point Charlie, which is the 090 meridian. This is where the vessel or the great circle track reaches its vertex. Moving further, as we proceed further from Charlie, we reach up to Delta here in the previous diagram. And in this diagram, moving ahead from Charlie, we reach up to point here, this particular point, which is Delta. Moving further again, the vessel reaches at this particular point and it is crossing the equator now from North Hemisphere to South Hemisphere. And this is point Eco in our previous diagram. Vessel is crossing the equator from North Hemisphere to South Hemisphere. So this is how the track is going to look like when you view it in the direction shown by the yellow arrow. And you can now clearly see that before reaching the vertex, the vessel is on a northeasterly course. The course is continuously changing. At the equator, it is on a particular course. The course keeps on changing, and as the vessel reaches the vertex, the highest latitude point, the course is exactly 090. After crossing the vertex, the course now goes into the southeasterly quadrant and vessel keeps on moving further ahead, and again it crosses the equator at point eco. After crossing the vertex, latitude starts to decrease because the course is southeasterly. Moving in the southerly direction, north latitude decreases and it again reaches at point delta and then eventually at eco, where it crosses the equator and goes into the southern hemisphere. We have only shown the side which is towards us in the diagram. The far side has not been shown here for clarity. So at the vertex, the great circle track as well as the vessel reaches its highest latitude, that's number 1. And at the vertex, the direction of the great circle track is exactly east-west 090270. So beta, any doubts in this now up to here?
No, sir.
Yes, sir.
No, sir.
Very good, beta. Great. Moving ahead.
Sir, can you please show previous slide as well?
Okay, I'll show you. This is the previous slide, beta.
Sir,
Thank you, sir. Thank you, sir. Noted.
Okay, beta. Go ahead, Nelson.
so can we find out the latitude of the vertex by calculating the inclination?
We can, beta. We can. I'll tell you how to find the position. It's coming ahead.
Okay, sir.
Okay. So we have understood what vertex is and what are the different properties of the vertex. Now, what are the use or utility of this vertex? Vertex helps us in quickly calculating the position of any intermediate point on the great circle. Now, using spherical trigonometry, we have done basic great circle problems. We have found out the great circle distance between 2 points. We have also found out the initial and final courses. But when we are doing great circle passage planning on board, we also need to find out, calculate or identify intermediate positions on the great circle track. These intermediate positions act as waypoints and helps us to plot our great circle passage on the chart. Now vertex helps us in quickly calculating the position of these intermediate positions. So moving ahead now, beta, I'll be showing you how to calculate these intermediate positions. Now, having understood the concept of vertex and its different properties, we are now going into how to calculate or find out the position of a vertex for a particular great circle track. Now, the first thing which we need to appreciate, a very, very important point for getting the position of the vertex, is that there are two possibilities for the location or position of the vertex. What are these two possibilities? One of the possibility is that the vertex may lie inside the triangle PAB. PAB triangle is the spherical triangle which we made for calculating the great circle distance and the initial and final courses. Now, one of the possibility is that the vertex lies somewhere in between the position A and B. That means the great circle track reaches its highest latitude in between the position A and position B, which are our initial and final positions. Now you can see this in the diagram. We have represented the vertex by point V in the diagram, and in this particular case the vertex lies inside the triangle PAB, or the vertex lies in between our initial and final positions. Now let's try to draw the meridian of the vertex. So exactly in the same way as Papa Alpha was the meridian of point A, Papa Bravo was the meridian of point B, Papa Victor is the meridian of the vertex. Now we are aware of two things here. One, that all the meridians, they run in north-south directions. All the meridians represent north-south direction. And second, we know at the vertex, the great circle track is exactly running in the east-west direction. So with the meridian running north-south and the great circle track running east-west, the angle of cut between these two has to be 90 degrees. So this tells us that the angle vector Papa Victor Alpha or Papa Victor Bravo, both these angles are going to be 90 degrees. I'll repeat once again. We know that all the meridians run in north-south direction. We know that the great circle track lies in the east-west direction at the vertex. The angle of cut between these two has to be 90 degrees between north-south and east-west. That is why angle vector of both the triangles Papa Victor Alpha and Papa Victor Bravo will also be 90 degrees. This is the first case. This is the first scenario where the vertex lies inside the triangle PAB, or the vertex lies in between our initial and final positions. Now there could be one more scenario or one more situation. The vertex may lie outside the triangle PAB. Let me show you in the diagram. Let's assume this is the pole. A is my initial position, B is my final position. Let's make the PAB triangle. You can see the PAB triangle coming up on the screen. Now in this particular case, the highest latitude where the great circle track reaches, or the position of the vertex, is outside the triangle PAB. You can see the vertex coming up as V in the diagram. This is where the vertex lies in this particular situation. Let's draw the meridian of the vertex. So Papa Victor maroon color arc which you see is the meridian of the vertex, and we know that the meridian cuts the great circle at a right angle, 90-degree angle at the location of the vertex. Meridian runs north-south, great circle track runs east-west, and the angle of cut between them is 90 degrees. This is the second possibility. So depending upon our initial and final positions, there could be these two possibilities. One, the vertex lying inside the triangle PAB, and second, the vertex lying outside the triangle PAB. Now for finding the position of the vertex, we need to find out that in that given question which we are solving, whether the vertex is inside the triangle or the vertex lies outside the triangle. This is the first thing which we need to know. Now let us see how do we find out whether the vertex lies inside or the vertex lies outside. Beta, any doubts up to here?
No, sir, all clear.
No, sir.
No, sir.
Very good, beta. Great.
सर एक डाउट था
बोलो बेटा.
सर इन केस इफ वी आर नेविगेटिंग फ्रॉम साउथ पोल टू नॉर्थ पोल फ्रॉम द इक्वल लैटिट्यूड, हम लोग जब इक्वेटर को क्रॉस करेंगे, इन दिस सिनेरियो वुड वी बी हैविंग टू वर्टिसेस, वन ऑन द नॉर्थ एंड वन ऑन द साउथ एंड, या फिर सिर्फ एक ही वर्टेक्स बनेगा?
बेटा आप एक हेमिस्फीयर से दूसरे में जा रहे हो, इनिशियल और फाइनल लैटिट्यूड्स अलग-अलग हैं या सेम है?
सेम है सर दोनों, जैसे हम लोग 10 डिग्री साउथ से 10 डिग्री नॉर्थ पे जा रहे हैं.
ओके, ऑल राइट. सो ऐसे केस में बेटा, इफ यू आर मूविंग फ्रॉम 10 साउथ टू 10 नॉर्थ, you can take any vertex of your choice because both the vertices will be equidistant from your track. आप कोई भी नॉर्थ या साउथ हेमिस्फीयर वाला वर्टेक्स यूज कर सकते हो.
ठीक है सर, मतलब कोई भी एक लेके हम लोग पूरा कैलकुलेट कर सकते हैं।
Exactly, you can do that.
ठीक है सर, थैंक यू सर।
Okay.
सर एक बार फिर बताएंगे कब अंदर होगा और कब बाहर होगा वर्टेक्स?
बेटा ये तो मैंने अभी बताया ही नहीं है, मैंने अभी पॉसिबिलिटीज बताई हैं, अभी मैं बता रहा हूँ आपको नेक्स्ट स्लाइड में कि अंदर कब होगा और बाहर कब होगा, कैसे पता चलेगा। ओके, सो लेट्स मूव अहेड एंड सी।
सर वन मोर क्वेश्चन, एंड जैसे साउथ टू नॉर्थ जा रहे हैं तो मतलब साउथ का लैटिट्यूड कम है एंड नॉर्थ का ज्यादा है, तो मतलब नॉर्थ वाले पे बनेगा, राइट?
That's right,
Vertex.
beta. You will take the north pole, you will take the vertex in the north hemisphere then.
Okay.
Okay, so let us see how do we find whether vertex lies inside or outside. So as we just now saw, we have to first check whether the vertex lies inside the triangle PAB or outside the triangle PAB. Now to check this, first of all, check the angle A and angle B of the PAB triangles. Remember when we did the initial great circle calculation, we obtained these two angles to find out the initial and final courses. So we have to have a look at these angles. Remember to check the angles of the triangle and not the initial and final courses. So reminding you once again here that when we apply the cosine formula to the PAB triangle, we obtain the angles of the triangle, angle A and angle B. Then we convert these angles to the initial and final courses. Now to identify the vertex lying inside or outside, we need to have a look at the angles, not at the courses. If the angles of the PAB triangle are acute, if both the angles of the PAB triangle are acute, acute means less than 90 degrees, the vertex will lie inside the PAB triangle. So this is the first condition. If both the angles of the PAB triangle, angle A and angle B, are less than 90 degrees, the vertex will lie inside the PAB triangle, or the position of the vertex will be in between the initial and final positions. Is it clear up to here, beta? Any doubts?
Yes, sir. Clear, sir.
Very good, beta. Moving ahead. Now, in case if any one of the angles, angle A or angle B, is obtuse. Obtuse means the angle is greater than 90 degrees. The vertex will lie outside the triangle. Let me show you with a diagram. We have the PAB triangle coming up on the screen. Now, in this case, angle A is a acute angle. It is less than 90 degrees. But angle B is a obtuse angle. You can see in the diagram, angle B is a obtuse angle. In this particular case, the vertex is going to lie outside the PAB triangle. Now, when it lies outside the triangle, the next question which comes to our mind is, on which side will the vertex lie? Will it go out on the side of the obtuse angle, or will it go outside on the side of the acute angle? So always remember, the vertex will always be towards the side where the obtuse angle is. So vertex will go outside the triangle and it will go outside on the side of the obtuse angle. So in this case, the vertex will lie somewhere here. You can see the vertex coming up on the screen now. We can now show the meridian of the vertex, and we also know that angle V is a 90-degree angle. So this is the second situation. Any one of the two angles being obtuse, the vertex lies outside the triangle and it will be towards the side where the obtuse angle is. Once you know whether the vertex is inside the triangle or outside the triangle, we can now find its position easily using the Napier's rule. Up to here, beta, any doubts?
Sir, instead of acute and obtuse angle, if the angle is 90 degree, then which side it will lie?
The angle is exactly 90, beta.
Yes, sir.
Okay, if you get an angle exactly as 90 degrees, then that position itself is the vertex, beta.
Okay, sir.
Okay, but it has to be exactly 90 degrees 0.0 minutes. Then that position is the vertex itself.
Okay, sir. Thank you.
Okay.
So do we have both obtuse angles in any case?
Yeah, you can never have two obtuse angle in the PAB triangle, beta. One angle will always be acute. So there are only two possibilities. Either both will be acute or one acute and one obtuse. You will never have two obtuse angles. Never.
Because the sum can't be more than 180, no?
नहीं बेटा, इसका जो सम है वो तो 180 to 540 कुछ भी हो सकता है, बट ऑब्ट्यूस एंगल दो नहीं बनेंगे बेटा. अल्फा और ब्रेवो कभी भी दो ऑब्ट्यूस एंगल नहीं बनेंगे, नेवर. अगर आपको ऑब्ट्यूस एंगल मिल रहे हैं, यू हैव टू रीचेक योर वर्किंग. सम मिस्टेक इज मेड समवेयर. Okay, great. So moving ahead now, beta, let us see how do we apply the Napier's find the position. Let's now see how do we find out or obtain the position of the vertex. Let's assume that in a particular situation, both angle A and angle B are acute, less than 90 degrees. And this tells us that the vertex lies inside the triangle PAB. We are just assuming this situation to look at the procedure. How do we obtain the position of the vertex? So let's make a rough diagram of the triangle PAB. You can see this triangle PAB here. Both angle A and angle B are acute angles. And we can see that the vertex lies inside the triangle. Now, in this diagram, we have two small right angle triangles. One of them is Papa Alpha Victor, PAV. It's a right angle triangle having a right angle at the vertex. And the second triangle is Papa Bravo Victor, having a right angle at Victor. Since both of them are special spherical triangles, we can apply the Napier's rule to any one of these triangles. So let's apply the Napier rule to triangle PAV, Papa Alpha Victor. So we have the same diagram here, Papa Alpha Bravo triangle with a vertex in between. Now, if you carefully look at the triangle PAV, Papa Alpha Victor, the known parts in this triangle are the side PA, Papa Alpha. The side PA, Papa Alpha, is the colat of our initial position A. And we are also aware of angle A of this triangle. The angle A of the triangle can be easily found using the basic great circle calculation using the cosine formula. So these two parts are known to us. So let's show them by a green tick mark. You can see a tick mark coming at Papa Alpha and coming at angle Alpha. Now let's fill up the Napier's cartwheel for this right angled special spherical triangle. You can see the cartwheel coming up at the bottom. We have the 5 parts. Bottom 3 parts having 90 degrees minus prefix. The vertex V having 90 degree angle comes on top. Going clockwise, the next part is alpha vector. The next part is angle A, so this becomes 90 minus A. Then we have side papa alpha, so the bottom part of the cartwheel becomes 90 minus papa alpha. Next is angle P, so this part of the cartwheel becomes 90 minus P. And the next part is papa vector PV, and we come back to angle vector of the spherical triangle. Now in the cartwheel, what we know is the bottommost part, that is 90 minus papa alpha. This is known to us. And we also know the right side part, which is 90 minus A. So you can see the green color tick marks coming at both the parts. Now, applying Napier's rule, we will find out the part papa vector of this triangle, or the side papa vector of this triangle. So you can see a question mark coming up on the diagram, and as well as in the cartwheel. So we have papa vector part, which is to be found. Now applying the Napier's rule here, the middle part is papa vector. So sine of middle part, sine of papa vector, is equal to cos of opposite part 1, which is 90 minus A, multiplied by cos of opposite part 2, which is 90 minus PA. Now both the parts on the right hand side, 90 minus A and 90 minus PA, are known to us. Using these two, we can easily find out what is the part PV, papa vector. This papa vector gives us the colat of the vertex. Exactly similar as papa alpha was the colat of position A, papa bravo was the colat of position B. Similarly, papa vector is the colat of the vertex. So PV gives us the colat of the vertex, and 90 minus PV gives us the latitude of the vertex. So latitude of the vertex has been obtained. Beta, any doubt up to here?
No, sir.
No, sir.
Very good, beta. Great. So let's now see how do we find the longitude. Anything coming to your mind? How do we find the longitude?
Find angle P.
Very good, beta. Great. So you can find the longitude from angle P. Let me show you. Now let's apply Napier rule once again in this triangle. Now this time we are going to find out angle P of the triangle PAV. So you can see a question mark coming up on the diagram. The angle P in the cartwheel is the left side part. So we can see a question mark coming up here also. So the bottom 3 parts are involved in the calculation now. And out of these parts, the middle part now is 90 minus PA. Other 2 parts are the adjacent parts. So applying the Napier's rule, sine of the middle part, which is 90 minus PA, is equal to tangent of adjacent part 1, which is 90 minus P, multiplied by tangent of adjacent part 2, which is 90 minus A. 90 minus PA, the left hand side, is known to us, and 90 minus A is also known to us. The only unknown here in the equation is angle P. So when we put the known parts, we are easily able to obtain what is angle P. Now if you look carefully in the diagram, this angle P is nothing but the d long, difference of longitude between alpha and vector. It is the angle at the pole contained between the meridian of alpha and the meridian of vector, giving us the d long between alpha and vector. Since we know the initial position of the ship, we know the longitude of position A. When we apply this d long to the longitude of A, it gives us the longitude of the vertex. So latitude and longitude of the vertex have been found out by applying the Napier's rule. Two applications of the Napier rule give us the position of the vertex. This is how the vertex position is obtained.
सर एक बार फिर से बताना सर, ये डी लॉन्ग केस का निकालने के बाद पी की वैल्यू निकालने के बाद।
बेटा एंगल पी निकाल लोगे आप नेपियर रूल से?
हाँ जी निकल गया। उसके बाद
ओके, एंगल पी इज द डी लॉन्ग बिटवीन अल्फा एंड विक्टर, ये भी आपको पता है।
यस।
So once you know the d long and you know the longitude of A, you can easily find out the longitude of the vertex. Let me give you an example. अगर A 30 degree east longitude पे है, 30 degree east, and angle P 40 degrees आ गया है, 40 degrees, what will be the longitude of the vertex, beta?
So it depends upon the side. How we know the long side?
Beta, the right side in this diagram is always the easterly side, as on the charts. The right side is always the easterly side. If you are going to right, you are going easterly. If you are going to the left, you are going westerly.
Okay, sir, understood.
Okay, so 30 degree east is the longitude of A. You are going in the right side direction, another 40 degrees. What will be the longitude of the vertex?
10 degrees.
70 degrees.
Very good, beta. It will be 70 degrees east. Clear हो गया बेटा? हाँ
Sir,
बोलो.
we have to find the angle P. Sir, can you use the sine 90 minus P equal to 10 Papa Victor into 10 90 minus Papa Alpha?
ओके बेटा, आप यूज तो कर सकते हो क्योंकि आपने पापा विक्टर भी फाइंड आउट कर लिया है. यू कैन यूज दैट पार्ट ऑल्सो. नेपियर रूल विल गिव यू करेक्ट आंसर विच एवर पार्ट यू यूज, but it is always recommended that when you apply the Napier's rule, use the parts which were known to you earlier. जो आपने पहले कैलकुलेट किए हैं उन्हीं पार्ट्स को यूज करना प्रेफर करो. Reason is that if you make a mistake in calculating Papa Victor, then that mistake will also go to angle P. But if you use the previous parts, even if Papa Victor goes wrong, angle P will still be correct.
Okay, sir. Clear.
Okay. As far as Napier rule is there, you can use any part of your choice. It will still give you correct answer. Beta, are you asking something? You are coming broken.
Yes, sir. I'm just asking, what about AV? AV, this distance. Because we have calculated alpha bravo, not alpha victor.
बेटा आपने बेटा पहला लेक्चर अटेंड किया था, फर्स्ट लेक्चर?
Yes, sir. Yes, sir.
AB डिस्टेंस तो बेटा हमने सबसे पहले निकाला था. AB डिस्टेंस निकालेंगे तभी तो हम एंगल A और एंगल B निकाल पाएंगे, राइट?
Alpha victor, how we calculate alpha victor? Because this is the mid part or somewhere.
No. Victor is not the mid part of between A and B. And हमें अल्फा विक्टर निकालना भी नहीं है बेटा. We don't want to find alpha victor.
Because in the Napier's we have written, sir. Yes, we have written alpha victor.
We have written alpha victor where beta? In the cartwheel?
Yes, sir. In the cartwheel.
बेटा कार्टव्हील में तो सारे पार्ट्स हमने फिलअप किए हैं, बट इट डज नॉट मीन दैट वी हैव टू कैलकुलेट ऑल द पार्ट्स. अल्फा विक्टर इज नॉट रिक्वायर्ड फॉर अवर कैलकुलेशन बेटा. अगर आप चाहो तो उसे ढूंढ सकते हो, कोई इश्यू नहीं है. नेपियर रूल वो भी सॉल्व कर देगा, बट हमें अल्फा विक्टर चाहिए नहीं बेटा. अगर कोई क्वेश्चन हो और उसमें वो आपसे पूछे हाउ फार अवे द वर्टेक्स इज फ्रॉम योर इनिशियल पोजीशन, अगर कोई क्वेश्चन में ऐसा पूछे, then certainly we can calculate alpha victor and give the answer.
Yes, sir. Okay.
Okay. Or doubts beta? वेरी गुड बेटा, ग्रेट, एक्सीलेंट. सो अब हम वर्टेक्स की पोजीशन कैलकुलेट कर सकते हैं. वी नो हाउ टू फाइंड द पोजीशन ऑफ द वर्टेक्स. नाउ आई एम मूविंग टू द फर्दर स्टेप. Once we know the position of the vertex, how to now calculate the intermediate positions? So let us go into that.
सर
बोलो बेटा.
सर ये मैंने फर्स्ट लेक्चर मिस किया था. ये जो कार्टव्हील में सर 90 डिग्री माइनस ए, 90 डिग्री माइनस बी है, 90 डिग्री माइनस बी लिखा है. तो सर एक जगह कई जगह आता था ना कि माइनस 90 आता था, मतलब 90 बाद में आता था. तो कौन सी कंडीशन होती थी सर? मैंने पहले लेक्चर लगाया नहीं.
बेटा वो कंडीशन होती है जिस ट्रायंगल में साइड 90 डिग्री होती है, साइड 90, उसमें बॉटम वाले पार्ट में 90 डिग्री पीछे चला जाता है.
एक साइड 90 होनी चाहिए.
Right. If you have a side 90, then when you apply the Napier's rule, bottom part में 90 will go in the end and the part of the triangle will come in the front.
ओके, मतलब अगर इस पार्ट में अगर PA 90 होता, मतलब तो हम लोग PA माइनस 90 लिखते. PA साइड अगर 90 होती तो इसका मतलब सर A तो इक्वेटर पे है. इसका मतलब अगर वो 90 है साइड तो.
That's right. If PA becomes 90, that means A is at the equator.
ओके ओके सर, ठीक है सर, थैंक यू.
Okay. All right. Moving ahead. Now, once the position of the vertex has been obtained, it becomes easy for finding the intermediate positions. The intermediate position problems can be broadly divided into two types. It could be asked to us in two different ways. The first type, or type 1, is you are required to find the position where the great circle track crosses a given latitude. Since the latitude is given, we need to find the longitude of that particular position. So this is type 1. They will give us the initial position, the final position, and an intermediate latitude, and they will tell us to find out what is the position where the great circle track crosses that particular latitude. Now in type 2 questions, you are required to find out the position where the great circle track crosses a given longitude. Since the longitude is already given to us, we need to find out the latitude of the position. Now in both these conditions, both these types, Napier rule is used to solve. Napier rule helps us to calculate the intermediate position in both types of questions.
Sir, in this type of question, this position which is asked is irrespective whether it is vertex or not, right, sir?
I didn't get your question, beta. Can you repeat?
Sir, in this two types of question which you just displayed, sir, this position is irrespective of talking about the vertex, right, sir?
That's right, beta. They can simply ask us find the position. So we should be careful that for finding the position, vertex has to be calculated first.
Okay, sir.
Okay. Moving ahead now. Now let's try to solve a intermediate position type 1 problem. We can see a PAB triangle coming up here. The angle A and B are acute, so the vertex lies inside. So you can see the vertex in between A and B. Let's assume that our initial position is at 30 degree north latitude and the vertex latitude is 50 degrees north. So in this type of question, they asks us to find out the position where the great circle track crosses a particular latitude. Let's assume that they want us to find out a position where the great circle track crosses 40 degree north parallel of latitude. So you can see this dotted line representing 40° north parallel of latitude, and it crosses the great circle track at this particular location. So this is the position which we need to obtain. So let's mark off this position where the great circle track cuts the 40° north parallel, and mark this position as X. And now let's join Papa X-ray. Papa X-ray basically denotes the meridian of position X. Exactly as Papa Alpha was the meridian of A, Papa Victor was the meridian of the vertex, Papa X-ray is the meridian of position X. Now you see the same diagram here. We have the Papa Victor X-ray triangle now. Please have a good look at Papa Victor X-ray triangle. This is a special spherical triangle, and we can now apply the Napier rule to this right angle triangle. So let's make the cartwheel. We have the parts coming up. The cartwheel is filled up. Now in this triangle, the known parts are side Papa Victor. Papa Victor is the collat of the vertex which has been obtained. So we know side Papa Victor. So let's put a green tick mark here. And the second thing which we know, the second part which we know is Papa X-ray. Since we know the latitude of position X, this parallel of latitude is given to us as 40° north. We know the side Papa X-ray. So these two parts are known. Let's identify these two parts in the cartwheel also. Papa Victor part and 90 minus px part are known to us. Now using the Napier's rule, we find out angle P of this triangle. So you can see a question mark coming up here at angle P. Applying the Napier's rule, you see 90 minus P becomes the middle part. Papa Victor and 90 minus px become adjacent parts. So Napier rule gives the relationship sine of middle part 90 minus p is equal to tangent adjacent part 1 tangent pv into tangent adjacent part 2 90 minus px. Right hand side pv and px are both known. So by putting these two values, we can easily obtain the value of angle P. Once angle P is found out, if you look carefully, angle P is the d long difference of longitude between Victor and X-ray. The longitude of Victor or the vertex is known to us. So when we apply this angle P, d long, to the longitude of vertex, we obtain the longitude of position X. Latitude was already given to us, longitude has been obtained, so position X is found out. ओके बेटा, हमने अभी वर्टेक्स की पोजीशन फाइंड आउट की थी ना पहले लास्ट स्लाइड में. सो पापा विक्टर इज द कोलैट ऑफ द वर्टेक्स बेटा. इस केस में ओके, इफ द वर्टेक्स इज एट 50° नॉर्थ, द वैल्यू ऑफ पापा विक्टर विल बी 40 degrees बेटा.
Sir, one more doubt. Sir, in this case, can we find XV, like the side, and then departure is equal to, D long is equal to departure upon MLAT? Will that be correct also?
No, beta, no. XV is not the departure. XV is the great circle distance between X-ray and Victor points. It is not the departure, beta.
Okay, sir.
Sir, in this question, it means the longitude of V will be given. Like we are applying the D long to V, so it means the longitude was given for V. That is why we
given, beta. We will have to find it first. हमने अभी पिछली स्लाइड में वर्टेक्स की पोजीशन निकाली ना, तो हमें निकालना पड़ेगा बेटा.
Okay, then we applied. Okay, so correct.
Right.
Excuse me, sir.
बोलो बेटा.
सर ये 40 डिग्री आपने नॉर्थ बिटवीन एक्स एंड वी लिया है. 40 डिग्री आफ्टर वी आल्सो, नो, so we can take it.
You got broken बेटा. एक बार धीरे धीरे फिर से क्वेश्चन बोलो.
सर मैं ये बोल रहा हूँ, ये आपने 40 डिग्री एक्स जो लिया है तो वेक्टर के पहले लिया, वेक्टर के बाद भी हो सकता है ना सर?
देयर इज ए पॉसिबिलिटी बेटा, ऐसा हो सकता है कि 40 डिग्री नॉर्थ जो है वो विक्टर टू ब्रेवो में भी इसे क्रॉस करे. बट अगर ऐसी सिचुएशन है तो क्वेश्चन में वो आपको इंडिकेट करेंगे. They will tell you find the position where great circle track crosses 40 north between alpha and Victor or the first time. तो आपको पता चल जाएगा कि कौन सा वाला पोजीशन उनको चाहिए. Okay, Naveen, got it?
Yes, sir. Thank you, sir.
Okay, beta.
Yes, sir, got it.
That means that firstly we have to calculate this vertex position, then we have to proceed for
Certainly,
triangle
beta.
P.
That is correct. आपको पहले वर्टेक्स निकालना पड़ेगा, तभी इंटरमीडिएट पोजीशन निकलेंगी.
Okay, sir. Okay.
Sir, we cannot find the position without calculating the vertex. I mean, so we can use the cosine formula.
No. Cannot find out, beta. Cannot find. Cosine लगेगा नहीं.
In this case, D long will be the west, right?
That is right, beta. When you are going from vertex to X-ray, you are going to the left side direction, so that D long will be westerly.
Okay, sir. Thank you.
Okay, beta. Great. So let's see type 2 problem now. I'm moving ahead. Now let's see an example of the type 2 problems. In these type 2 intermediate question problems, we are required to find out the position where the great circle track crosses a particular meridian or longitude. Let's assume that our initial position A is at 30 degree east longitude, and we have also calculated the position of the vertex. So let's assume the longitude of the vertex is 50 degrees east. Now this question tells us that we need to find out the position where the great circle track crosses this particular meridian. This is 40 degree east meridian. So we have drawn this dotted line representing 40 degree east meridian, and let's assume that this particular point is X, and we have to now find out what is the position of this point X. Now we will again apply the Napier's rule, in this case to the triangle Papa Victor X-ray. So let's mark the cartwheel. Let's fill up the parts of the cartwheel. You can see the cartwheel parts are filled up. And in this triangle Papa Victor X-ray, let's identify the parts which are known to us. Now one part which is known to us is Papa Victor. Papa Victor is the colat of the vertex. The vertex latitude longitude is already calculated, so we know what is the colat of the vertex. And the second part which is known to us is angle P of this triangle. Angle P is the D long, difference of longitude between the vertex and position X. You can see this is the angle at the pole contained between the meridian of vertex and the meridian of X. So we have the longitude of vertex, we have the longitude of the unknown position 40 degrees east, vertex is 50 degrees east, so we know what is the D long. So these two parts are known. Let's mark them in the cartwheel. Papa Victor is known and 90 minus P is known. Let's now try to find out the part PX. You can see a question mark coming up in the cartwheel. This is what we are trying to find out. So we apply the Napier's rule and we use the adjacent formula in this case. Sine of 90 minus P is the middle part, is equal to tangent PV, PV is adjacent part 1, multiplied by tangent 90 minus PX, which is adjacent part 2. So PV is known to us, angle P is known to us. So putting these two values, we can easily find out the side PX, Papa X-ray. Once we obtain side PX is the colat of the position X. So 90 minus PX gives us the latitude of the position X. Thus the unknown position, intermediate position, is obtained. So you see, using the concept of Napier rule and using the position of the vertex, we can easily obtain intermediate positions on the great circle track. So doubts coming up in this beta?
Sir, longitude of P, which we found it in the previous problem.
Longitude of Victor beta, the vertex?
Negative, sir. That D long P. Angle P, which we found in the previous question, that we are going to use over here, sir, 90 minus P.
No beta, no. This angle P, which is mentioned in this triangle, is the D long between vertex and X-ray. Vertex longitude is calculated. Earlier, we calculated the position of the vertex, and longitude of X will be given to us. So we have to find the D long between them. That will give us angle P.
Okay, sir. Thank you.
So clear beta? Clear up to here?
Yes, sir.
Very good beta. Great. So this basically completes the calculation of the vertex and the calculation of the intermediate positions.